Hi guys, welcome to IGCSE on Fingertips. I am Divyang and today I am going to teach you redox reactions, the electrochemistry as a whole. First part of this is redox reactions. So let's first understand what does redox reaction mean and what do these basic words and definitions mean. So redox reaction, reduction, right? Red stands for reduction and red ox. So ox stands for oxidation, right? First definition I would say is reduction is removal of oxygen, and second definition I can say is addition of oxygen, right? Let's have a look at this with an example. So copper oxide reacts with hydrogen, right? We know that hydrogen is more reactive than copper oxide, but I'll still need to heat copper oxide for hydrogen to displace copper from its metal. So copper oxide plus hydrogen would give me copper plus water. Now copper is losing oxygen, so removal of oxygen is reduction. Hydrogen is gaining oxygen, so gain of oxygen is oxidation, right? Addition of oxygen is oxidation. Now we have another definition, because not all redox reaction we see will involve oxygen, right? To understand that, let's take another example, right? This another example is nothing but sodium plus chlorine, right? Sodium solid, chlorine as gas, will react to produce sodium chloride. Sodium forms a sodium ion by losing two electrons, and chlorine forms a chlorine ion by gaining these two electrons, right? So there is an electron transfer taking place. This is an ionic bond. But also from the perspective of this reaction, and I will show you that oxygen also does the same thing, we will understand that redox reaction can also be understood by transfer of electrons. So you have to just remember oil rig. Oxidation is loss of electrons and reduction is gain of electrons. Now let's look at the example we previously did. So copper oxide reacts with hydrogen to produce copper plus water. Now just let's look at copper. The oxidation state of copper is +2, right? This is also known as its oxidation number. The charge on ion is oxidation state or oxygen number, sorry, oxidation number, not oxygen number. And here the charge is 0, so oxidation number is also 0. How can copper 2 plus become copper? It must gain 2 electron, right? And remembering oil rig, oxidation is loss, reduction is gaining. Copper is gaining electron and copper oxide was reduced, reduction is gaining electron. So both the ways copper 2 plus ion is getting reduced. Generally positive ions are the one that can gain electrons, right? Therefore metals generally will get, metal ions will get reduced, non-metals can get reduced to form negative ions. Okay, so this is that. And if you look at hydrogen, okay, so what is happening to hydrogen? Hydrogen was simply a diatomic gas, but on acceptance of two electrons that came from copper, it becomes, sorry, not acceptance of two electrons, which is why I wrote it like this, sorry. So hydrogen becomes H plus by losing the two electron, right? To here, to balance the reaction, these two electrons are used by copper to become C, right? Again, even without oxygen we can understand, due to electron transfer, what is a redox reaction, right? Let's see. Now we have an example. In redox reaction, what happens is, if one thing gets oxidized, the other gets reduced. They are taking place simultaneously. That is why they are defined in one word, redox reaction. Now we will see here that one of the agent is getting reduced, the other is getting oxidized. So chlorine reacts with potassium bromide to form potassium chloride and bromine, right? This chlorine, it was atomic in form of molecule, right? It was molecular chlorine. This molecular chlorine is now an ion when it is with potassium chloride. How can this happen? This can happen only if chlorine is more reactive than bromine, because it is displacing bromine from its compound, which is true because chlorine is above bromine in the group 7. In group 7 we have seen reactivity decreases as you go down the group. Now if you look here, bromine ion becomes bromine gas, right? So something is happening to bromine as well. Now if I just remember oil rig, oxidation is loss of electron. Who is losing electron? Bromine. Bromine, as I said previously, non-metal ions can get reduced. Non-metal ions can get oxidized. Metal ions can get reduced. Non-metals can get reduced, and metals can get oxidized. Okay, so just an example of that fact, that bromine ion, right, it is going to lose electron. So if it was non-metal, it can get reduced. If it is non-metal ion, it can get oxidized. So non-metal ion is getting oxidized, it is actually losing electron. So it is oxidation, right? Here what is happening, it is a non-metal, it is gaining electron, so reduction is taking place, right? And something else we can understand here, chlorine is itself getting reduced, but in the process of itself getting reduced, it is also oxidizing bromine. So chlorine is not only getting reduced, it is also oxidizing bromine, therefore it is also known as oxidizing agent. And chlorine being oxidizing agent, in the same manner I can say bromine is a reducing agent, because the one that gets oxidized is reducing something else. If it is reducing something else, it is known as reducing agent. Now to write the summary of all of these things, right, we have questions like this. Okay, so I will call this part of the reaction and this part of the reaction, or the half equation, right? I will call this half equation. What half equation is this? What is happening here? Chlorine is gaining electron, so I will call this reduction half equation. For this and this, I can call it oxidation half equation, or oxidation half reaction. When I find total of both of these reactions and cancel out the common things on both sides, what I get? I get the ionic equation, or I may say that this is the redox reaction that is actually taking place. This is where the ions are getting changed. This is where the electrons are changing their place, right? So we understood here reducing agent, oxidizing agent. How is oxidation taking place? How is reduction taking place? And this happens because chlorine is more reactive than bromine, right? Now, as I have already showed this to you, that oxidation number, right, it is the charge on that ion, right? So looking at an example here, manganate 7 ion, you will learn in transition metals or metal properties that this number 7 is nothing but the oxidation state of manganese in this particular compound, right? It goes from 7 to 2. Now for manganese to go from 7 plus to 2 plus, right, sorry, it needs to accept 5 electrons, right? Only then this can happen. Acceptance of electron or gaining of electron is reduction, right? So if itself gets reduced, right, reduction, this is a very good oxidizing agent, right? This oxidizing agent shows its oxidation power, indicates its oxidation power with color. For 7 plus ion, the color is purple. For the 2 plus ion, the color is colorless. So if I take let's say sulfur dioxide gas, and I take a strip which is uh, I have dipped this strip in manganate ion, right? Solution of manganate ion. And if I expose this strip to sulfur dioxide can be oxidized to sulfur trioxide. When sulfur trioxide is being oxidized, this gets reduced and therefore it will change the color to colorless. This is an indication that the oxide was oxidized further, right? There is only one oxide that right now we know can be oxidized further, which is sulfur dioxide. So also a test for sulfur dioxide. Now coming back to the redox reaction topic, so I was trying to explain that when the oxidation number decreases, reduction has taken place. A fall in oxidation number means reduction has occurred. Okay, and we have an example where we will see that this is also reduction. Okay, similar change, similar logic. Just another example which is in our syllabus, that dichromate goes from 6 to 3, which is reduction, which is again meaning that this is an oxidizing agent. But iodine, it is colorless. Iodine is, oh, I don't have the pen. Iodine is colorless, right? It gets oxidized and becomes red brown. Now its oxidation state went from -1 to 0. Now if you just see, that diagram was nothing but a number line. So you have 0, you have 1, 2, 3, 4, -1, -2, -3, -4. You go rightwards, oxidation number is increasing, that is oxidation, right? For iodine, we went from -1 to 0, so that is oxidation. And from for magnet, we went from 7 to 2, and from chromium, we go from 6 to 3. Both of these are reduction, right? So just by looking at change in oxidation number, I can say if this is reduction or oxidation without remembering what happened to electrons. So for example, Fe2 plus becomes Fe3 plus. This can be done only if it loses electron. But if I don't remember this, I can just say oxidation number increasing. This is oxidation, right? That is the implication here. Now you know what is oxidation, what is reduction. We will now understand what is electrolysis and how is it done. For that, let us start with very basic things. There are conductors and insulators, right? Conductors that are liquid, that can basically liquids that can conduct electricity, are known as electrolytes, right? This is the B part of our topic, which is what will we call this? We will call this electrolysis, right? Its name is electrolysis. It's not that we call it electrolysis, but yes. So electrolyte, a liquid that can conduct electricity. There are two possibilities. What can this liquid be, right? The two possibilities are: one, it is molten ionic compound, right? And other possibility is there, it is a solution of ionic compound. Why so? Why can it be only these two things? Because it needs charge carriers, right? Here, current is going to run. So battery, the current from positive to negative, right? Not writing anything inside the electrolyte right now. I'll show what happens. But current from positive to negative, but electron flow from negative to positive, right? Just remember this change. Electron flow is from negative to positive. We say current is from positive to negative. Now coming back to electrolysis. So if this liquid under the test does conduct electricity, this bulb here will start glowing. If this liquid under test does not conduct electricity, this bulb will not glow. This glows only if it is a molten ionic compound or a solution of ionic compound, because only these two have charge carriers, right? If I take pure water is polar, but it does not contain iron. Because it does not contain iron, there are no charge carriers, right? So let's understand here what is what. Electrolyte is the liquid that conducts electricity. These graphite rods they have taken are known as electrodes. They are the rods that are connected to poles of the battery dipped into electrolyte. Battery is nothing but your power supply, right? The flow of electrons is going to be very, very important for us, right? Flow of electrons is going to be very, very important to us, which is how we will find out where does reduction take place and where does oxidation take place. Just 1 second, let me have a look. What do we have next? Okay, so the next thing we start with simply, right, electrolysis of molten lead bromide. We just understood that it needs to be a molten or liquid ionic compound. So molten, right? Ionic compounds are generally solid. So when I close this switch here, what happens? This rod becomes negatively charged. This negatively charged rod, I'll say, attracts. These are facts, okay? Whatever I'm writing here, these will be facts. You can use them wherever in electrolysis you want them to. Here we'll write our observation. This will be valid for only this. So negative rod always attracts cation ions, and hence they are known as cathode. Okay, positive always attracts, as you might have guessed, anions, and therefore known as anode, right? Now, what are the positive and negative ions in this solution? The positive and negative ions are lead plus and Br minus, right? Lead plus or 2 plus, let's say PbBr2. I think it's okay if we write Pb plus. So let's use that only. Let's use Pb plus, right? Lead plus. This lead plus being positively charged will travel to the negative electron. This bromine minus being negatively charged travels to the positive electron. Now let's see what happens at cathode and what happens at anode. Okay, I will write the reaction here and I will write what do you observe here, because a lot of times, not a lot of times, almost always they will want you to write what do you see, because let's have a look at cathode. Okay, first, so cathode, it is the negative electrode, so cations go there. What is the cation? Cation is lead. What will happen to lead if lead goes near the negative electrode? I think I'll have to move this. If lead goes near negative electrode, it will for sure at get attracted to it, accept one electron from it, and become lead, right? Lead metal. What will happen at the anode? Your Br minus, it gives Br plus, accepts one electron. Okay, but because bromine is a diatomic gas, it gives off not just one electron, it gives off two. It gives off bromine plus, it gives off two electrons, right? And 2 Br minus will be there to balance this whole thing. But what will you observe? You will observe a silver, not silver, let's call it a gray metal depositing, right? And what will you observe on the anode? Brown gas being produced, right? Because sometimes they will ask you what do you observe at anode, what do you observe at cathode. Now we are so busy in remembering what is happening here, I will immediately write this answer. I will completely forget that they are asking for observation. They are not asking that what is the reaction, they are asking for observation, right? We should always remember what they are asking for and then write accordingly. Okay, I think this should be completely visible. You can pause the video here, make your notes, right? But these are the observation. Gray metal, I don't know where it went. So acha, it's here, a gray metal depositing. Okay, so that is the reaction here. Now we have not yet talked about the electrodes. The electrodes are rods. but they are transferring electricity, right? When they are transferring electricity, they themselves need to be good conductors. There are two types of electrodes. One is known as inert and one consumable. They will get consumed, right? We will see some consumable electrodes later on, but right now, until unless I specify it, we are using inert electrodes. Inert electrodes, they don't take part in the reaction except giving and taking electrons. Okay, it will just transfer electrons. It will not get dissolved, it will not get used up. Okay. Now at the negative, oh, it is selection, sorry. So at the negative electrode, electrons are coming, right? I'm trying to teach you, just a second, let me zoom into this. So I'm trying to teach you what is the path of ions and what is the path of electrons. To do that, let's erase this a bit. You can always go back and make your notes, pause it wherever you like, right? Okay. So yes, I was saying that this circuit is complete, right? So electrons travel from the negative pole to the negative electrode. Then there are metals here. So the electron goes and reduces the metal, which means I can always write, okay, let's write it here, reduction at cathode. And if reduction is taking place at cathode and they are simultaneously taking place, even without proving it to you, I can say oxidation at anode. We will see in a while how oxidation is taking place, and you don't even need a while. If you look at here, bromine is giving out electrons, oxidation is loss of electrons. So that is oxidation. Coming back to the journey of electron, so electron is getting used up here. But I told you that electron goes from the positive electrode to the positive terminal, the positive pole of the battery. So from where does this electron come? Okay, this is where that electron is coming from. This electron goes back into the battery. Okay, so this is where that electron is coming from. Reduction at cathode, always true. Oxidation at anode, always true. Now sometimes they directly ask you what is the path of positive ions and what is the path of electron. So electron path is this, right? Only here there are no electrons traveling, there are ions traveling. So if they ask you positive ions, you always point towards negative. If they ask you negative ions, okay, if they ask you negative ions, you point towards positive. Okay, I hope this much is clear. Moving on to next electrolysis example. So here we are using dilute sulfuric acid. No, let's do this. Instead of dilute sulfuric acid, yeah, let's use dilute aqueous sodium chloride. Okay. So everything remaining same. Cathode attracts cations, anode attracts anions, reduction at cathode, oxidation at anode, right? Let's let's see what happens. Okay, so reaction and observation, right? This is what we are going to fill these things with. I should write this here. All right. Okay, so let's start with that. Now I have taken dilute sodium chloride. So what will happen now? I have in the solution, right, in these tubes, I have H plus ion and OH minus ion. Where did these come from? It came from water. It splits. When there is an ionic solid dissolved in water, water splits to H plus and OH minus. When water is in its pure form, there are no impurities, there are no additions. Water stays as a covalent compound, although polar, right? And sodium chloride dissociates to Cl minus and Na plus. So now you have two positive ions and two negative ions. We need to decide which one will get reduced and which one will get oxidized. Now I've written this reactivity series. This is helpful in so many places, but this is especially helpful to understand that sodium is much more reactive than hydrogen, right? This is a very huge gap, and sodium wants to stay as ion. That is how it is stable. That is how its outermost shell of electron is full. So what will get reduced? Hydrogen will get reduced. So what will the reaction be? The reaction will be hydrogen. Reduction is gain of electron. So 2 hydrogen plus go and gain 2 electrons to form hydrogen molecule. What is your observation? Observation is bubbling, right? You can also write effervescence, you can also write gas produced, but bubbling and effervescence are the best answers, I suppose. Then at oxidation at anode, right, what happens is, again chlorine and OH, the number of OH, the concentration of OH is much higher. So this is a reaction, this particular reaction that I'm going to write, you have to remember it. This is how it happens. Okay, we don't have to go into detail that how exactly this happens, but it so happens. I'll explain you as much as I can. So 4OH minus, it splits into O2 plus 2H2O plus 4 electrons. Okay, it splits into O2 plus 2H2O plus 4 electrons. What is happening? Oxidation is loss of electrons, and here it lost 4 electrons. The whole equation is balanced, but importantly oxygen is produced. So what you will observe? You will still observe bubbling on this particular electrode as well, right? If the electrodes were made of graphite, right, which is nothing but carbon, the gas produced will be CO2, carbon dioxide. The oxygen produced will react with the carbon to produce carbon dioxide. So for this particular electrolysis reaction, carbon is not an inert electrode because it is getting used up, right? So they can trick you with these kind of questions. With graphite, platinum is also an inert electrode that we can use. Okay, just to remember. Now we have concentrated. This brine means concentrated aqueous sodium chloride. Okay, concentrated aqueous sodium chloride. So just like last time, you have sodium plus, chlorine minus, but it is aqueous, so you have H plus and OH minus, right? Let's see what happens. So we'll have reaction here, we will have observation here. Okay, let's see. Reaction, we'll write cathode and anode. Okay, I'll explain this whole thing, but let's first write the reaction. So cathode, let's give it some space, and there is anode, right? Now at cathode, what will happen? H plus, right? Because sodium is very much reactive. So the same reaction, 2H plus gains 2 electron because reduction is taking place to give H2, right? At anode, what is happening? Now the concentration of chlorine is much greater. So Cl minus, again because it is a diatomic gas, to balance I'll take 2Cl minus. What does it do? This becomes Cl2. How does it do that? By losing 2 electrons. So oxidation is taking place. Chlorine has lost 2 electrons here. What is your observation? Your observation is effervescence, right? I think the spelling is wrong. Okay. Effervescence. Okay, so effervescence is taking place, and here obviously effervescence is taking place because the chlorine produced is in the form of gas. Also, I have not written everywhere, but if it is a redox reaction, you are expected to write state symbols. So wherever I have not, please, when you're making notes, include state symbols. So effervescence is taking place here. Here yellow green gas is produced. Okay, now I have written effervescence, bubbling. Is it okay if you write colorless gases produced? Yes, it is. Right? The only colored gas here is yellow green gas is produced. There is one more situation where you will observe something happening. In this, what you will see what is the observation of this reaction. You will see that the yellow green color fades and the solution becomes brown in color because there is bromine now in the solution. Okay, so this is also a question they can ask in your exams, and this is how you can answer to that question. So yellow green gas is produced. That is your observation. I hope you understood the reactions for electrodes. Now let's see what is happening here. Now you add sodium chloride, the dilute sodium chloride here, sorry, concentrated sodium chloride here, right? It's coming in. Now this is an asbestos wall, which is a membrane, right? It lets only sodium plus transfer to this side. It does not let chlorine go. So here the concentration of chlorine keeps on increasing because H plus and OH minus can go anywhere, right? This is a titanium anode. What will happen at titanium anode? Just as we saw, chlorine gas is produced, and because it is a gas, it goes upwards, and you can collect this chlorine gas. There are a lot of uses of chlorine gas. You can understand them from your textbook. If it's new edition, you will not find it because it is not in syllabus like this. You just have to remember those equations. You don't have to understand the uses and that kind of things. Now, what happens at the cathode? Reduction at cathode. So hydrogen gas is produced. This is a colorless gas. Again, it can be collected upwards. Now, what is left? Right? This is very important. If you look at the solution, you had sodium plus, H plus, Cl minus, and OH minus. There is no more chlorine. There is no more hydrogen. What is left? Sodium hydroxide is left. So what happens to the sodium hydroxide? You can take it out. But if there was no asbestos wall, I can still say that the pH of this solution with the progress of electrolysis decreases because H plus ion concentration is decreasing, right? Hydrogen gas is forming, so H plus ion concentration is decreasing. So pH slowly starts going toward basic side, and this is a proof that base is actually produced. Okay, they can ask you questions like this, that what is the pH of the solution, what is the change in pH of the solution, and why does this happen. Then we have the first, not the first, but a depleting electrode, right? We have already seen graphite as a depleting electrode, right? It is getting used up, it is not inert in those conditions. Now this is to show you what happens to the electrolyte when you take certain types of electrodes and what is the arrangement. So again, a simple electrolysis arrangement. You have copper sulfate solution, right? Copper sulfate solution is Cu2 plus, SO4 2 minus, 2 plus, sorry, 2 minus, right? And because it is a solution, you have H plus and you have OH minus, right? Let's see what happens at cathode, what happens at anode, what is the reaction, and what is the observation. Okay, so let's look at cathode. Cathode is the positive one, sorry, cathode is, cation is the positive ion, cathode is the positive one. So you have Cu2 plus and H plus. What is more reactive? H plus is more reactive. So Cu2 plus will be made to accept 2 electrons to become copper metal, right? Where will this copper metal go? It will get deposited on the cathode. So a golden yellow, you can say brown, you can say orange. Orange is the best bet, but golden yellow solid deposits on cathode. That is my observation for cathode. What happens at anode? Anode, first let's write the reaction. So you have OH minus and SO4 2 minus. For all intention and purposes, SO4 2 minus, NO3, all of those kind of you would say complicated ions. There is no redox for us of those complicated ions. So you can just easily ignore this. You can behave as if this does not exist in your electrolysis. Okay. So at anode, same old reaction that we are made to remember. 4OH minus gives O2 plus 2H2O plus 4 electrons, right? What would you observe? You would observe bubbling of colorless gas, right? Bubbling of colorless gas. Now let's understand a few important things about this reaction. Okay, this is this is something interesting that takes place. Now what happens to what happens in this reaction is, if you see this copper ion that we have, right, the copper ion that we have, it goes on decreasing, right? It is depositing on this cathode, so copper ion goes on decreasing, and therefore the blue color of this solution starts fading. So if you take inert electrodes and electrolyze copper sulfate solution, the color of the solution will go on fading, right? But what happens when you don't use an inert electrode? Let's see, that is going to be interesting, which is going to be basis of purification of copper. Now you have copper anode, you have copper cathode. Because you have copper anode and cathode, they are going to take part in reaction. One is going to increase in size, one is going to get depleted, so they are not inert anymore. And you have copper 2 plus inside your solution, right? Obviously it is solution, so you do have H plus and OH minus, right? Now what happens at the anode? So at the anode, basically copper, so I'll write this time anode here, or let's not do that, let's keep it simple as always, and let's start from the cathode. Okay, what will happen at cathode? We have Cu2 plus ions in the solution and H plus. Obviously Cu2 plus will accept 2 electrons and become Cu metal, right? What will you see? You will see that again so and so metal depositing at the cathode, but the cathode is itself made of that metal, so I will write size of cathode increases, है ना? If the size of cathode is increasing, it means we already know that it is made of copper, so copper is depositing on the cathode. Let's look at anode. What will happen at anode? So at anode, copper being very less reactive, it is made to form Cu2 plus ion and give out 2 electrons. What will happen here? From here, Cu2 plus ion will go into the solution and 2 electron will travel towards the power supply. Okay, maintaining the directions as we have seen. What will you see? Size of anode decreases, right? Why does this happen? Increases because copper is being deposited on the cathode, copper is depleting from the anode, because on the anode copper is getting oxidized, on the cathode copper is getting reduced, copper ions are getting reduced. Okay, now they are saying that blue color does not fade. Why so? Because what is happening here? The anode is giving copper 2 plus ion and the cathode is taking these copper 2 plus ion. But because electricity is constant, right, on both direction, only then the mass conservation can be maintained, right? Only if 2 electrons go from here, 2 electrons can be accepted here. Therefore, the rate of losing Cu2 plus ions is equal to rate of Cu2 plus ions at cathode, let's write, is equal to rate of gaining Cu2 plus ions at anode, right? Which is why the color does not fade, which is why concentration of Cu2 plus remains constant in the solution and therefore the solution does not fade. I hope you understood this. And using this logic, we can use, just a second, why color did not change. We can use, I hope this is visible, we can use electrolysis of copper using copper sulfate solution in purification of copper. What will happen here? Not here. Copper ions will start going to the electrolyte. Copper ions from the electrolyte will become copper and deposit on the cathode, which is made of pure copper, and slowly you see that the size of the cathode increases. Slowly the size of the anode decreases. But what is this? This is known as anode dust. Okay, anode dust is basically dust or some sludge containing precious metals. Because copper is very less reactive, it is becoming iron. But elements that are even lesser reactive than copper, copper wants to stay in the iron form, so even lesser reactive than copper here, they will not be able to become iron, and therefore staying as metals, right, they will stay as solids which are insoluble. Okay, if the metal would dissolve, it means that the metal is reacting with this liquid, right? But it is not able to form iron, because in competition copper saves gold, right? So silver and gold, only those two, and platinum are precious than copper, and they will not form iron until unless copper is there, copper metal exists. Till then they will not become iron and they will fall down as dust. I can clean this dust using filtration. I have my copper cathode which is pure copper, so I can use this for making wires or things like that, right? Using the same logic, what logic? That metal can travel from anode to electrolyte in the form of iron back as metal on the cathode, happening due to redox reaction with the help of power supply. We can use all of this thing to do something known as electro plating, right? I'll do electroplating, meaning plating a less precious metal with a more precious metal in order to increase its value, in order to make it look better, in order to stop its corrosion. So what are the things required? See, I require metal as my anode, right? Here it will be silver metal with which you want to electroplate, right? I really hope this pen is visible, with which you want to plate, right? Here you should attach utensil or item to be plated, and because electrolyte you need ion of this metal going from here to the cathode, you need salt of this precious metal, right? Now if you have understood, if you have gone through acid bases and salts, you would know which salt is soluble and which is not. But like me, if you don't always remember everything by heart, if you understand things logically, then just for this instance, remember nitrates are always soluble. Any nitrate is soluble, right? So we have taken, hopefully this is visible. If it's not, we've taken silver nitrate solution, this is silver anode, and we've taken steel jug as a cathode. I will leave this blank for, oh, before I leave this blank, I'll take a pen. I'll leave this blank for you to answer, right? Basically, what is happening? Silver is depleting. So on anode, you will write the silver anode depletes, right? On the cathode, you will see silver depositing slowly, right? Silver solid depositing. What will happen? One silver will become Ag plus and it will lose an electron towards this direction. A silver ion from the silver nitrate solution, or the one that is from the anode, will go and stick to the cathode to form Ag plus electron gives Ag, right? So this is happening. I've already given you the answer. So this is happening at the cathode and Ag gives out Ag plus electron. This happens at the anode, right? Hopefully you can write the observations on your own. So this is electroplating. Now, not directly part of this chapter, but I think we should be doing hydrogen fuel cell in redox reaction. Although this also includes energy changes, but in simple terms, what is happening is that we know hydrogen reacts with oxygen to produce water. Now, hydrogen can be directly used as a fuel just like petrol. It will burn, it will give out a lot of energy. You can convert this lot of energy and run your car, or for any intention purposes you deem fit. So the product is water. This can be considered a green fuel because it is not producing carbon dioxide. But what is happening behind the scenes, or what is happening which we are not able to see, is hydrogen hydrogen, right? It produces H plus and loses 2 electrons. These 2 electrons go to oxygen, right? Oxygen gains 2 electrons to become O2 minus. But because there are two O2, I'll write 2 here, and I'll write 4 electron, 4H plus and 2H2 here, right? Which means this is the balance in the reaction, right? So this is what happens. If I make this electron transfer, right, for here as well, if I make this electron transfer through an external circuit like this, what will happen? I can run something on current directly, okay, without charging. So what can happen, if the number of energy transfer decreases, the efficiency of this particular machine will increase. We want to use this at our advantage. Now how do we do this? Okay, let's understand it here. You can go back in the video and make your notes, but I need to erase this part to make you understand better. Let's see. So what happens is, hydrogen from the hydrogen fuel tank goes into this part of the box. Okay, there is some electrolyte here, I think potassium hydroxide solution, right? It requires OH minus ions. What will happen here? H plus, right? H plus, so our H2, I'll not balance this, but H2, sorry, becomes H2H plus 2 electrons are given off. These 2 electrons travel in the outer circuit. H plus goes into the electrolyte, or rather H plus stays in this electrode and it gains OH from the potassium hydroxide. So H plus, it has given off electrons, it gets OH minus. So what will happen? This will become water. So your output, if you see, your output is water here, right? Now what happens on the other side of the electron? You have oxygen coming in from air. Carbon electrodes contain a catalyst which will promote this reaction, right? Both of the side we have carbon electrodes. These carbon electrodes, what will they do? This oxygen and there is water, right? So reverse of, if you remember this equation by now, right? This equation takes place in the opposite order. Oxygen comes, this oxygen then adds to the water, right? And it gains 4 electrons that are coming from the hydrogen and produces 4 OH minus, right? Produces 4 OH minus. So how many ever OH minus are absorbed by hydrogen, that many OH minus are given off when oxygen combines again, right? Now, because 4 electrons, hydrogen gives 1 electron each and 4 electron produces 4 OH minus. So this whole situation is balanced, right? So the concentration of OH minus, just like the concentration of Cu2 plus, will remain constant in this electrolyte. Only water is produced. Because only water is produced, this is a good fuel. And as this was done using electrons from hydrogen, you don't require a very sophisticated system, you just require a hydrogen fuel cell. Okay, I hope everything was clear till now. If you require worksheets, if you require more explanation, or if you require anything else regarding your IGCSE or Cambridge syllabus, please let us know in the comment box below. You have our email, you can join our Discord, and you can also go to Instagram and send us message there. But right now, thank you for watching this video. Hopefully we'll come back with more videos and a worksheet for this topic. Thank you for watching again. Bye bye.